remember on our last topic, we had discussed on the geotechnical failure. One of the failures was what was it? Anyone would like to tell me? What was geotechnical failure that we had discussed last week? Nur Aina Amira? Cik Nur Aina je kan, last week pun Nur Aina. Muhammad Zarif? Mana Muhammad Zarif ni? Dia menghadirkan
Ada,
sekadar. Okey, apa yang kita bincang last week ah? Apa salah
excessive
satu?
settlement.
Okay, good. What were causes to the failure? One of case history that we had discussed on excessive settlement, and then what was reasons behind the historical building failures?
Landslide, madam? Bukan.
Landslide. Okay. But landslide will be covered in detail for these sessions. So if you look at back to the last class, we had discussed on differential settlement, excessive settlement, and I leave it for you to have some sort of the bearing capacity failure that we covered on the type of incline factory building, and I remain every one of you on the excavation topic. Okay, just refresh balik what we had last class on the differential settlement. One of the causes due to the failure is stresses on the soil, because the building on the historical building was carried different loadings on the section A, for example, and then had a different stresses on the section B, and due to the what we call it as a water effect. So these are the causes contributed to the excessive settlement or differential settlement to the historical building. So on part of the bearing capacity, we had seen that some sort of the where the authors of the textbook represented to you how they come up with the forensic processes by defining causes to the bearing capacity failure, and then some theoretical behind the failure, such as how do you conduct the analysis, bearing capacity analysis, and then what can you do to mitigate by having some sort of the mitigation technique, such as by having strength in very good soil, or you can having reanalyze on certain calculations to have a good bearing capacity. So those are the things that we had learned last week. So for this week, I am going to focus on the slope mitigation or slope failure in geotechnical hazards, and the other things on that. If you go back, there are so many cases that we can relate to the geotechnical failures, but today we be concentrate on the slope stability failure and how we can conduct the geotechnical forensic in this type of failure. Before we go further, let me share to you a very good I think that's very good info regarding the geotechnical hazards, where we can have some sort of the idea what's exactly of the geotechnical hazard awareness. So let me start showing to you.
The next section will discuss the main types of geotechnical failures that occur in open-cut coal mines. In excavated slopes, these include planar, wedge, toppling and composite failures. In dumped material, these include active-passive wedge failures. Failures that may occur in both excavated and dumped slopes include circular failures and isolated rock fall failures. Planar failure. These types of failures occur where a block of rock slides along a single defect that dips and daylights in the excavated face. Wedge failure. Wedge failure occurs where two continuous planar defects intersect and daylight in the excavated face. Toppling failure. Toppling failure occurs when persistent defects dip steeply into the excavated slope and the blocks or columns formed topple out of the face. These failures generally have a weak layer at the base that the vertical blocks slide along. Composite failures. These are typically the most common type of failure in excavated coal mine slopes. Composite failures involve a combination of planar, wedge and toppling failure modes along persistent defects, and also some component of rock mass fracturing and failure. Typical composite failures are vertically to subvertically bound by structural defects and horizontally bound by a weak, generally carbonaceous layer. Such failures occur at both the individual bench scale or as a failure of the overall pit slope. Active-passive wedge failures. These type of failures occur in dumped slopes, particularly where the dump is formed on a weak and/or steeply dipping floor. Circular failures. Circular failures occur in highly weathered, soil-like or dumped material that contains little to no large rock fragments. Circular failures may be deep-seated or may occur near the surface where they are referred to as skin slippage failures. Circular failures typically result from an excavated or dumped slope that is greater than the angle of repose through undercutting or over-steepening mining practices. Isolated rock falls. These are failures in which individual rocks fall out of a dumped or excavated slope face. Isolated rock falls can be just as hazardous as failures involving a whole slope face. They generally occur after heavy rain events, where poor separation of dumped material has occurred, or where blasting has been poorly executed and the face not adequately scaled for loose rocks at the time of mining.
Once a geotechnical hazard has been identified, an inspection will be completed as per site requirements. Controls will then be put in place to effectively manage the hazard. Controls must be followed at all times. If you observe conditions to change from those documented in the site hazard report, notify your supervisor immediately.
Typical controls to manage geotechnical hazards using the hierarchy system include elimination controls, scaling or chaining of slope faces and crests to remove loose rocks, trim blasting to remove unstable ground, redesign or engineering controls, altering the blast design, such as changing from a hard wall to a soft wall, installing temporary buttresses, reviewing and redesigning the mine plan, such as incorporating additional benches into both excavated and dumped slopes. Only allowing equipment with falling object protection installed to work within the hazard zone. Separation or isolation controls. Controlling access at the crest or toe of the identified hazard by installing hard barriers. Restricting to single lane access past the hazard. Limiting equipment used in the hazard zone, such as allowing the excavator arm and bucket only inside the hazard zone, or modifying or restricting the dragline dig sequence to minimize exposure to the hazard. Regrading or re-establishing tip heads. Rectifying drainage conditions, including installing pumps and grading slopes away from the crest into a sump. Administration controls. Increasing the frequency of inspections, allowing only experienced operators within the hazard zone. Completing additional risk assessments for specific mining sequences, such as mining on retreat or backfilling after mining coal. Establishing monitoring controls, such as PEG telltales, wireline extensometers, prisms, LiDAR or slope monitoring radars. Restricting operations to daylight hours only or installing additional lighting. The number and nature of controls is governed by the consequence and likelihood of a slope failure occurring. Slope monitoring and implementation of standoff zones are two of the most commonly applied and effective controls if managed correctly. Slope monitoring is completed by one or more of the following methods: visual inspections, PEG telltales, wireline extensometers, prism monitoring, laser scanners, drone surveys, LiDAR or slope monitoring radars. Monitoring devices can be used for either long-term, broad-scale detection of slope movement or targeted monitoring of a specific area of concern. Regardless of the monitoring device implemented, it is important to remember the following. Monitoring devices deployed should be able to measure the direction and magnitude of slope movement. Monitoring backsite devices need to be mounted on stable ground, otherwise false or misleading measurements can be recorded. Monitoring equipment needs to be regularly inspected and serviced to ensure it is operating as required. Trigger or alarm levels need to be predefined and should be set at levels specific to site conditions. Standoff distances can be applied at both the crests and toes of excavated or dumped slopes. Standoff zones are typically based on empirical charts, past performance of slopes with similar conditions, or modelling results from software simulating individual rockfalls or slope failures. The applied standoff distance should be appropriate for the type, size, likelihood and consequence of slope failure. Many sites have standard restriction zones that are applicable at all times. Increases or decreases to these standard restriction zones are then made on a case-by-case basis depending on the specific hazards present.
Okay, I think that you have seen and watched the geotechnical hazards. So what we can say is that the video shows to us the causes of the slope failure, and then how we can mitigate by controlling some techniques, adopting some monitoring, adapting by having advanced technology to control and monitor the slope failure. It says that by integrating the technology into our decision making, administrative work, and also the monitoring process, it can prevent future failure. So the purpose that we can see from this learning outcome is to understand what are the causes and what theories involved in the analysis and design, and how do you mitigate to prevent any future failure, and do some forensic engineering steps, that, solutions, and then you propose it by having some sort of guideline from the public authorities, from any departments that we deal with the project site fail. So these are the things that will be covered in today's sessions. So as you can see just now from the video, it only presented the most cases in any countries facing from the excavated slope. So just now, when you saw the video, it's indicate that this rock failure is coming from the different sizes of the natural existing rock. So the rock falls can be triggered by the human activities such as excavations. In somehow Malaysia, for example, that we receive a very heavy rainfall that also can produce prone to have some sort of the landslide, debris flow. So how are we going to mitigate in our way in Malaysia, for example? Is it okay we adopt the same technique from overseas, such as in Australia, bring into Malaysia? These are the things that when we propose any technology in your mitigation work, for example, you are coming with a forensic report, is it suitable that we use this kind of the methods? And then how about the risk on the budget issue? And are you fulfilling the public authority requirements? So those are the things when you are proposing a report for your forensic engineering project. you have to check on these certain issues. For example, knowing by identifying your case project, what type of failure and what's the application it is, what causes trigger to the failure, for example, and then how you come up with the solution in terms of the design, analysis, theory, concept, and you are proposing the mitigation, the technique on the site, for example, and then how do you verify and how do you adopt the parameters from site and also lab bringing to your design and solution mitigations. So lastly, you propose a rectification work so the client can accept whatever it is, because all must be written and documented so it's easy to view and report. So we go to our notes today. So if you look at from this one, actually, before we can highlight on any type of geotechnical hazard or failure, we have to understand the theory behind it, because the theory will give you some assumptions, understanding, and then you starting to digging out, you start to identify, and then you do some investigation, carry on to the analyzing, and finally you develop a mitigation technique. So adopted this note from Prof. Madia Muhammad Jamaluddin. I will explain on the slope categories and slope failures and any cases that can be highlighted, and also try to elaborate and having some sort of discussion among you, just to what we call it, to refresh what we have learned in the soil mechanics and also from the geotechnical engineering or geotechnics. So the video just now showed to you how was the slope may fail due to the human activities such as excavations. So the most closely slope failure can occur on the excavated slope. However, if you look at to this type of slope, we can categorize slope into two groups. For the first one, natural slope, and the second one, we call it as a man-made slope. So the engineered slope or the man-made slopes also can be categorized into few types. For example, cut slope, field slope, retaining structure slope, and also the rock slopes. So the rock slope, if you look at to the video just now, it focusing on the mining area, because the mining area having some sort of excavation activities that the people require the block of rock to convert or to processing into a cement. And then when you go to here, for example, there's something that can be find out from the slope fail. For example, at the bottom of the figure, the slope failure of a road embankment. So what are causes? If you can see here, some kind of you have to identify rock failure type. Is it circular, planar, or wedge failure? Because all those categories of slope failure will bring to you the causes of the slope itself, the slope failure itself. And then how do we do the detailed investigations? For example, from the failure or from the fail site, we're going to take a short sample, bring to the lab and do some experiments to identify the residual strength of the soil and what are the strength parameters at the failure zone. And if you go on, if you go to site also, once you identify the slope failure, for example, circular slip circle or rotational slip circle, we will take the sample at the slip circle to bring to the lab to identify what are the strength parameters during the time, because the most critical for the slope failure in the long-term stability. So at that time, the slope will carry the residual strength instead of the peak stress or the peak strength or having the ultimate strength of the soil. So not to forget, the natural slope also can be occurred. So it's not say that the slope failure only happen due to excavation activity. It also can happen in the natural slope. So what are the reasons? For example, if you take one case closely in Malaysia, just take it to the what we call it Yan recreational area, and then most likely happen in Baling, for example. So the natural slope failure is triggered by the heavy rainfall. But then when we do some sort of forensic activities, and we found that there was an evidence showing some human activities on top of the hill, on top of the slope. So we want to investigate these factors that brings to the landslide or incoming slope failure. So it says that if you do not have any kind of the slope failure that bringing water, so it's just only the soil mass that maybe not what we call it, that may not be harmful compared to the slope failure coming with a landslide, and then on rock failure. For example, in Bukit Lanjang, Malaysia, we also having rockfall. So the rockfall can cause to the pavement damages. So when this thing happened, for example, in Bukit Lanjang in 2003, there were massive blocks. Apa benda tu? Ada siapa-siapa ke cakap? Ke ada benda yang you nak bagi tahu? Okay, never mind. So we back here. So this only part introductions, some causes or what. So the images telling you the case history in Malaysia, or in other words, telling that the slope failure can cause or can triggered by rock falling or from the soil movement. So by definitions, I think that every one of you quite understands lah when talking about the features of the slope failure by having some sort of the terminology, and understand what how the process begin, starting from the weathering itself, from the intact parent rock become weathered from the class 1 to the classic weathering grades, and making the rock into soil form, and having some sort of lesser in strength, that when you go on details, for example, you construct any structure on top of the slope, on top of the hill, for example, they give some additional load. So the additional load can bring to you on part of the safe slope or unsafe slope. So how are we justify, is it the slope safe or unsafe? We have to do some sort of analysis. Okay, on the slope materials, if you go to the slope materials, we have so many deposits such as alluvial, glacial, alien, residual. So all the deposits are what we call it are defined by some of the weathering process, such as if you go to here, residual deposits are formed in place by mechanical and chemical weathering of their parental bedrocks. So in this forensic, when you do some sort of the detailed investigation, it's not looking at the geotechnical aspect. So maybe your site near to the geology origin, geology background. So need to find out what is the rock or what is the parental rock in the site area. So when you have this kind of the parental rock you have identified, you can support your final decisions. Is it your structure is stable to be built on this kind of parental rock, for example. And due to the process of weathering, having some weathering agents that bringing one material to another's bringing one material at one side to another side, and causing to the original soil into the weathered zones, and making the what we call it in terms of the strength itself is already changed from the originally to the form weathering made. So when you go in details also, we have also marine deposit, and these are the things when talking about the slope, it's not only on the hill, it can be at the riverbank slope, or any structure dam slope. So you have to see on surrounding ourselves what it can be categorized as a slope is. slope. By definitions, you can see the slope is blah, blah, blah. But from the geotechnical, from the technical aspect, the slope can be in any ratio of dimension between vertical and horizontal dimensions. So now we go to the concept of the slope stability because we're talking about the slope failure. Before you can categorize your slope in what types of it, either rotational, circular, slip failure. You have to understand how it is derived. From the understanding of the basic mechanic, which is having some frictional force, and then we have normal force, and the normal force is equally to the effective stress, and the what you call it, the relationship between the frictional force and effective force, the one coefficient we call it as a nu. So the deriving from this one can be adopted similarly when you want to define the stability of the slope by having the shear stress equal to effective stresses, tangent effective FEB. So the dashed red line indicates to you the slip circle. So we have the shear strength that acting to the soil, and also the shear stress that resists to the failure. So one force acting bringing to the soil mass fail, and the other force in opposite direction try to resist any kind of the movement or failure. So remember, when you do on the manual calculations, we have so many formulas or theories behind it. Either you are analyzing in the effective stress or long-term stability, or you analyzing in the total stress analysis or in the short-term stability. So it is the most important parameters in the slope stability coming from the shear strength, either C and also the FEB. It depending on the soil itself, the originality of the soil. Either you have coarse grain or you may have a fine grain, meaning that when you go to site to identify the causes of the failure, you might see on the slope pattern, slope type, and then the material of the soil mass, the mass soil fill, is it coarse grain or is it fine grain? What's are important because the visual inspection will get the visual inspection and also observation will telling you what will be probably the strength of the material. Most likely we can have some sort of idea, or this kind of the green soil, we might have a very low strength, high strength. If we have a fine soil, we might have a low strength. So that is the first impression when you want to investigate any kind of the failures. So remember again, by adopting any method of slices for here, we are dividing our soil mass into few vertical slices, and then we starting to calculate, determine the factor of safety, and identify what is the disturbing forces or stresses, and what is the resisting forces, and also the resisting stress. So when you have the FOS equal to 1, we can say that the slope is stable. And the same thing that we adopt in the slope stability using the effective stress concept. So effective stress concept, meaning that you only have effective stress equal to total stress minus with the pore water pressure. U here indicate as a pore water pressure. However, most likely the slope failure may occur due to the unsaturated conditions. So what is the unsaturated conditions? It's a condition where the slope mass may fail in the regions of the on upper part is unsaturated in the dry conditions, and then at the below part is the saturated conditions. So by using the simple effective stress analysis or concept might not be enough to have the correct answer if you are analyzing manually. I mean that the old theory, the old concept, the might not be relevant to face or to give the right solution nowadays. So it came by any other theoretical from any other researchers such as Bishop and then further learn, introduce to you the concept of the unsaturated soil. Why this concept or theory unsaturated soils is important? Because when they found out that the slope fail is not due to the effective stresses subjected to the water pressure only. It also can be happen due to the air pore pressure. So that's why from this Moore column formula or the Moore column theory has been extended by including the suction effect for unsaturated soil. So right now you may see that just now we only have effective C plus sigma effective tangent effective P. Now the formula is being extended by including the effect of the air pore pressure minus with the pore water pressure. So you can see that on the part of the failure surface will be changed. So if you remember, if you have taken the course on the advanced geotechnical engineering, we have seen on the critical stress path, and then the failure envelope representing in the QP space. So you can see when you plot the Moore column failure and compared to the advanced theoretical formula, that will be totally different in terms of the failure envelope. So the failure envelope for the advanced theory can be what we call it, can be observed any uncertainty that could not be predicted using the Moore column theory. So that's why starting in 1978, the formula produced by Fredlin Modeston and the other co-researchers, so they formulate and then they what we call it, they try to uh, telling that how good by having unsaturated soil theory in order to calculate the factor of safety. So not anymore the stress is as simple Moore column theory. You have to include the effect of the suction. UA minus UW is a suction. We call a suction. So I think that this slide is not showing to you where is the region unsaturated and saturated. But never mind. So we go to the next modes of the slope failure. This is also being seen just in the video. We have a slope failure, some kind of the base failure. We have also the shallow slope failure. We also have the translational slides. So basically, when you see on this type of the slope circle, two circle, that telling you the critical of the slope failure, the identifying of the center of the slip circle. Remember when you are analyzing the slope manually, we already given to you the sector angle of the critical slip surface. For example, 40 degree, or the slip circle occur at the 90 degree. The center of the slip circle will tells you what is the value factor of safety. So it says that by identifying the center of the slip circle, you can calculate the disturbing forces, and then you can calculate the resulting forces, and finally you can also have the factor of safety value. Ideally, we can say that again, as mentioned, when you have this kind of the factor of safety ratio between disturbing forces and also the resisting forces or moment, if you have the value equal to 1, so the slope is stable. If you have this value less than 1, the slope is unstable. So the conditions of the analysis must be taken seriously. Either you are calculating for the long-term stability or for the short-term stability. How do we know that this kind of the analysis being carried out for long-term or short-term stability? By looking to the applications of your analysis similarly to your strength parameters. Okay, this slide telling you what are the causes triggering to the slope failure. The first one is a pore pressure increase or the rise of the groundwater table, and the other one is the erosion. Erosion again is also a product of the weathering process, the soil stratification, soil degradation and weathering, the presence of the tension crack, the vegetation cover, the change of the stress condition, rock mass discontinuities, and the last one is the rock mass state. So I am not focusing on the failure due to raw or due to soil. You just take it generally. How do you know or how do you identify the causes of the failure itself? Okay, what are the important items that need to be carried out when you try to evaluate the stability of the slope? The first important, as I said, is the shear strength of soil. So the shear strength of soil, if you see from the Moore column theory or for the formula, the shear stress is depending on the effective friction angle and also the internal, the cohesion, internal friction angle and also the cohesion. So the next one is on the slope geometry. The slope geometry is telling you what is the dimensions for the slope itself vertically and horizontally, or you can have the slope geometry in terms of the angle. So if I am not mistaken, in the geotechnics course, the last topic in the chapter 3 telling you what are the mitigations or any kind of the remedial work can be taken to prevent any slope failure. And the other one is on part of the vegetation itself. So now, when we're talking about the sustainability, nowadays the engineers try to adopt how the slope can be sustained by using a environmental friendly. For example, here the vegetation, instead of having a soil anchoring or having the shotcreting concreting, we can also cover our slope field using the vegetations. So the vegetation is naturally as a bio process where the root of the vegetation act as a binder between the soil particles. So it is also a biogeotechnics in mitigation for anything failure happen in the future. I mean, if you go to any kind of the mitigation work or techniques, there are many examples such as using the what we call it geotech style. We also can has deep foundations by having some piling, and we also can use anchoring, and then we can have some kind of the retaining wall. So instead of using these methods that might not sustain in terms of sustainability, which not environmental friendly, we can opt for the other one using the vegetations and also the berm techniques. So the berm creating for having a many sizes of the slope or many sizes of the berm to prevent any future slope failure. And other thing that need to be considered during the analysis for slope stability is loading and environmental conditions. Loading and environmental conditions, for example, if you travel along the highway express from the north and south expressway, you can see on the left and right sides of your journey some sort of the excavated rock slope. So the excavated rock slope is not only covered by we call it as a mesh or any blanket or any rock cage. It's also provided a drainage. So the purpose of the drainage to allow water infiltrate or water flowing through it, so that within the rock structure there is no water collections that can make it the rock become weaker. So it also can be as part of the additional forces that acting to the rock. Similarly, if you have any kind of additional loading on top of the hill, and then you are not providing any kind of the drainage, you may something that you will face in the future having a kind of slope failure. So most of the cases in the slope failure in Malaysia lah, if you take the simple case on top of the uh, hill, so we can see due to the heavy rainfall, or the other thing is due to the construction undertaking, or in Penang itself, if you travel to the island near the what we call it, balik pulau area, in the balik pulau, how the condition for the natural slope itself, is it being covered by anything to prevent the failure. So these are the things when you go around your when you go anywhere surrounding yourself, you need to start thinking of as a geotechnical engineer. Let's say you are passing by a road, and then you, as the video show lah, you can see this site might prone to have a future failure. How are you going to mitigate or control it from happen? The failure may occur in future, but how do you minimize it so that it will not cause to the high risk or in losing many life, or giving as effect to the economy or to the cost itself. So back to the suction, one of the causes, the pore pressure effect. As I said, the pore pressure is not coming only from the water, it also can come from the air. So the unsaturated theoretical concept adopted the suction theory. So looking to here, the suction is the difference between the air pressure with the water pressure. So in the field, air pressure is 0 atmospheric, which is 0 kPa, and the pore water pressure is negative. The conversion occurs at the negative 101.3 kPa or 1 atmosphere. So if you look at to this concept, this is what it says, that the slope failure may introduce to two different zones. But for the first one is the unsaturated, and at the bottom one is the saturated zone. So not anymore, we can only simply use the Moore column theory. This particular problem, especially in the slope stability applications, the theoretical behind the failure must be adopted using the advanced technique such as unsaturated conditions. So unsaturated condition that may see from here is to increase the shear strength and producing the higher FOS, factor of safety. So this is the benefit about including the suction effect to your theoretical concept. So I will not explain detail here because we are not covering for the unsaturated soil. But it's good if you can have some sort of overview. So this is how, just remember the conditions of the unsaturated height, and then how the effect of pore water pressure, and also the pore air pressure, and the soil mass itself above the soil, above the slip circle, and the conditions that splitting between the unsaturated zone and also the saturated zone. Okay, the factor of safety concept can be analyzed. So just now we're focusing on the concept and design, adopting the proper theoretical formula. Somehow, the analysis also can be calculated using the limit equilibrium analysis, and also using the factor of safety through the finite element method. So the FOS are derived from the summation of forces in two directions and moments about a common point. So the calculation for stability of slope are performed by dividing the soil mass above the slip surface into vertical slices. If you are adopting limit equilibrium analysis such as method of slices, Bishop, and Fellinius. Okay, itu je yang kita nak explain. Maknanya kata kalau if you remember what had you done in the past using the manual calculation to calculate FOS, so that we call as a limit equilibrium method. So understand the ratio between the SU and also the shear stress required. We tell you the value of FOS. Okay, the shear strength model. This is again as I said, the advanced shear strength formula and theory to calculate the FOS in slope stability. So look at the failure surface. So the failure surface is not anymore as a straight line, but as assumed by Moore-Coulomb model. So right now you might see that the circular envelope in curve that representing the conditions for suction. So that's why it says that including the suction will increase the strength itself and also the FOS. Okay, you see here how it is deriving and indicating to you the zones of the failure from different perspective view of theoretical formula with unsaturated concept or unsaturated theories. Finally, this formula or from this slide showing to you that there are 4 equations and 7 parameters involved. Remember, I am not sure are you taking the advanced technical engineering, but the advanced technical engineering, one of the soil models is Moore-Coulomb. The simplest model in understand the behavior of the material, either structure or soil, we are using the Moore-Coulomb formula. The good things about Moore-Coulomb is only need about 5 parameters. The strength parameters and also the stiffness parameters in total are 5. However, when you go to the advanced theoretical theories such as here, when there is more equations involved, meaning that there will be more parameters are required to complete the equations or analysis. So the parameters from experimental can be used in the formula equations. So now you can see that how are we deriving the parameters from the first parameter, number 1, number 2, 3, 4, 5, 6, and 7. So we need to determine one by one all those value from this failure envelope, the circle of the failure envelope of the soil. Okay, this is another concept to calculate the FOS using the limit equilibrium method. So I hope that every one of you remember we are dividing the soil mass into few vertical slices, and then we define and we determine the disturbing moment and also the resisting moment to get the FOS. Okay, generally, what we understand, the FOS decreases when water table rise. So, yang tu yang benda yang kita memang biasa nampak lah kan. Kalau, if even now, we can see that the public authority already installed one monitoring gauge to predict the failure of the soil, integrating with the internet, or we call it as a IoT. So this monitoring gauge will tell the authorities the soil movement. Is it the soil movement in the range of the stable, or the soil movement in the range of unstable? So it is a mitigation and also the controlling techniques to predict before having the massive failure. So, okay, this is slope stability during the rapid drawdown, and also the potential slip plane due to rainfall infiltration into slope of unsaturated soil. All these informations, I think that it can be seen from the slide in mind for the future. And also, if you're looking to this image, how it is presented using the soil phase model, having water and then the soil grain, soil particles, and the water infiltrate through the slope face, and how does the water infiltration give the rise in groundwater table and affecting to the potential circular failure plane. Okay, the next one, we go to the other notes slide given by practitioner engineer. So it is started with the landslide causes. So I think that the same thing that we had seen just now. So one of cases here, very common and very famous, was Bukit Antarabangsa. So I think that some of you had already took this case, investigate from the structural aspect failure. But now you have to see from the geotechnical aspect failure. I mean that, is there any poor water pressure existence at the failure zone? And then what were the slope failure causes and the slope failure mode? That so these are the information can be highlighted in your report. Okay, similarly to Bukit Lanjan, Ulu Kelang. Okay, again, this one is very general information on the case description. And how does the slope may occur or the landslide? So the same concept, having the friction and then sliding effect and telling you the resisting and disturbing forces. One force try to disturb, the other force in different direction try to resist it from fail. And then the effect of the water pressure. How does the water pressure reduce the value of FOS and the suction effect? So you can see that the suction effect here, by replicating the frictions concept here, and similarly showing the suction increases in N forces will increase the value of force F. And why the landslide occur? From this table, given in 2010 by these two practitioner engineers, stated that out of the 49 cases, 29 or 60% were contributed due to the design errors. So what are the common design errors can be happen here untuk landslide? Siapa boleh bagi pendapat idea kenapa agak-agaknya daripada banyak-banyak punca landslide ni, dia katakan design error adalah faktor utama? Agak-agak sebab apa? Kita panggil Azman bin Zahari. In your personal opinion, why do you think that the landslide reported by these two engineers was due to design error? Any reason why? Agak-agaknya lah. Mana Azman bin Zahari ni? Ada ke tak? Sebab apa?
Movement of the soil.
Okay, dua engineer ni, dia bagi report mengatakan daripada punca-punca landslide ni, antara punca terbesar disebabkan oleh kesalahan ataupun design errors. Design errors, apa pendapat awak? Kat mana yang boleh berlaku design errors ni? Agak-agak ni kat mana? Masa stage apa selalunya boleh berlaku design errors?
Kait dengan FOS tak, Madam?
Okay. Betul. Selain daripada tu, apa yang main factors dia? Dalam FOS tu ada apa? Ada nilai apa? Nilai apa? Dalam FOS tu, kalau you tengok yang paling penting parameters adalah shear strength kan. Macam saya cakap tadi lah, bila kita analyse, sama ada kita nak analyse for short term ataupun long term stability, dia merujuk kepada shear strength parameters. Is it the stresses in effective ataupun in total stress? Kadang-kadang tu bila kita nak analyse FOS tu, bila peringkat design, kita tersalah pilih strength dalam condition yang tadi tu lah, macam saya cakap, sama ada undrained condition ataupun drained condition. Itulah yang dia katakan design error antara punca berlakunya failure kepada landslide. Design error ni juga bila you salah pilih conditions of the parameters either in drain condition or undrained condition, they can give you different. I mean that you are trying to design for, of course, for the long-term stability, right? But then you are wrongly pick up the parameters. You are taking the parameters for short-term parameters. So the consequences in the future, maknanya bila you salah ambil parameter yang sepatutnya for long term stability, tapi you ambil for short term stability, dia akan memberi impact kepada design. Memang betul you akan dapat FOS 1. But is it true for the life span our construction to sustain, to retain any kind of failure in the next 10 years or 5 years, for example? So these are the things that can be contributed due to the human error in design. Okay, back to our slide just now. This slide is very important because we can see from the different perspective view of the practitioner engineers. For the first slide just now, you saw from the perspective of the academician. That's why you can see the details formulations in terms of the strengths and also how the unsaturated concept being adopted in the slope stability analysis. You can see that there are very tedious processes to identify the equations and then the parameters to produce the right failure envelope. So from academician point of view, now we look at from the engineer perspective point of view. So looking to here also, when you go through from row by row, similarly, the design and constructions errors only contributed 20%. So the rest are from maintenance, geological features, construction errors. The construction errors can due from the site supervisor may not monitor work properly, and then the geological features, for example, the presence of the weakness plane being not counted in your analysis for and then the discontinuity of the rocks. So these are the errors that being triggering to the landslide. So design and construction, if you look at to here, one of the there are three things listed here. First is the prescriptive method, insufficient SI, lack of understanding of the soil mechanics. This is what I said just now. Insufficient SI, for example, let's say we are trying to produce what we call it a preliminary investigations on the design and analysis. For example, this is not involved with the failure yet. So we try to produce at the first stage of design. Due to insufficient data, parameters from the site exploration, it also can give to you to the wrong analysis of the stability itself. I mean that maybe due to the budget constraint, you couldn't do site exploration. You cannot do standard penetration test. You only can do on the JKR probe test. So you are relying the result from JKR probe test to have the kind of slope stability analysis. Maybe it's not enough, and or maybe it is enough during that time, but may not enough to to have a good design for the future or for the long-term stability. And the lack of understanding of the soil mechanics. I mean that in the, let's say you are taking the course advanced geotechnical engineering. In the places, there are different way to to tell you that even though you are analyzing for the clay conditions or for the clay soil, you also can analyze the clay behavior in the drain analysis or in the drain conditions. So by good understanding, we tell you that the right soil strength parameters can be adopted or can be applied in your calculations. Another thing is that due to the slope geometry design. The slope geometry design, if you look at to here, let's say you are trying to have a cut slope, and then you are proposing a slope geometry as a 1-to-1, one vertical, one horizontal, then you can get the angle. So the angle here, for example, is 60.75 with the height of 16 meters. If you look at here, do you think that the slope is stable with the angle of 60.75? Vertical is 1 or 60-meter high. If you let's say you are the engineer on site, do you think that the slope geometry design is safe or something that can be affected to the slope stability? Another thing is that when you have kind of the soil properties, if you make a comparison between a slope 1 and also the slope 2, by having a different geometry, for example, here the height of the slope is 6, similar to the slope number 2, but the horizontal from the crest of the slope to the two of the slope is a 13.2, whereby the slope 1 is only 7.5. I mean that from the horizontal distance from the crest to the two slope is 75. We can see that how does the soil properties and the slope geometry design will be affecting to your factor of safety value. So it is indicates that from here, the slope number 2 is unstable due to the soil properties itself and also due to the slope geometry. The selections of the slope geometry is not right. So it says that the slope geometry can be changed to the 1 vertical to 2.2 horizontal. So this is the best slope dimensions for the number 2 case slope. And you can see here, for slope number 1 and slope number 2, the effect of water table is neglected. So kita tak masukkan kesan air. How about if you are dealing with the slope that having the effect of water table? Of course, you are adding more additional pressure to the soil mass. Not to forget, when we are correcting the slope failure or proposing a slope analysis, there are some guidelines or reference factor of safety can be used as your indications. For example, if you are analyzing by adopting a manual from this office, for example, from the government of Hong Kong, it says that how the slope can be categorized into negligible risk, low risk, and also the high risk, according to the factor of safety value, and also to the what we call it here, the effect of economic loss, and then the loss of life for a 10-year return period rainfall. So when you analyze it, you are also considering the effect of rainfall for the next few years ahead. So it's very crucial for this because we are dealing with the unsaturated conditions, and then there's some hydraulic or we play around with the hydraulic concept, the Darcy law, the intensity of the water, and how does you are doing the predictions on the hydrology in terms of the water rainfall for the particular period of years. Okay, if you're looking to the soil strength for calculating the stress or for calculate the FOS, you can see that how does this effective friction angle having a relationship to the fineness of the materials, and how does this friction angle give the value of FOS. So on the left and right side indicates to the slope where it has each of these slope has similar in the effective frictions angle and also the effective cohesion 1 kPa and also 33 degree. Slope left, slope right having a similar value. As you notice from these two slopes are different on the factor of safety is due to what reason? Kalau you boleh nampak apa punca nilai FOS kiri dan kanan berbeza? Apa sebab-sebab dia? Nadia, apa yang you boleh observe? Sebab let's say you put yourself as an engineer, you pergi ke site, boss you kata, okay, pergi buat investigation slope field dekat kawasan sekian-sekian. Okay, apa yang you nak balik report pada boss you? So the same thing here lah. I give you two condition. Kita ada slope 1, kita ada slope 2. Kenapa slope yang berdekatan sebelah kiri tak fail, slope belah kanan fail? Apa punca dia? Siapa boleh jawab? Okay, siapa boleh jawab? Apa sebab dia? Siapa boleh jawab? Daripada dua gambar kiri kanan ni apa menyebabkan satu FOS lebih daripada satu? Satu lagi gambar FOS kurang daripada satu. Apa punca dia? Apa punca dia?
Sebab cara cut slope.
Pandai. As I said in the earlier 1 hour class kita tadi kan, I said that one of the remedial slope protection by having a bumps on your slope. But somehow, if you have so many bumps on the slope face, also not stable. For example, on the left side of your slope, we only have one slope face with the center of circle at that point 1.032 producing FOS. And also on the right slope, having the same soil properties, dry condition, weight of soil is 18, cohesion 1, feed 33. But now you can see that there are many bumps involved. For example, 1 slope face, 2 and 3. So there are 3 slope faces, meaning that there are 3 bumps. So we can conclude that as what we have so many bumps, there will be decreasing the factor of safety value. So it's not good for having such as many bumps. So it will produce to you low FOS. Okay. The other things that we want to see on the effect of slope itself lah. Kalau you tengok sini, the slope geometry is 45 degree. But now here, on the same slope design, we have different berm dimensions and also different geometry of the berm itself. So now, we can conclude that by having so many berms, that will be reducing your value of FOS. So you can analyze FOS for slope stability using limit equilibrium method in the slope W, or you can analyze the slope stability in the fast way using the finite element method in Plaxis. So I am offering you, because you are trying to produce a report, right? So a report that you chose, for example, saya tengok senarai projek tu ada yang dekat college, ada yang dekat mungkinlah kan flat area, ground flat area yang mana tak ada pun any prone of slope failure. But when you are doing the investigations for your building failure or etc., you also can include any other important information, such as your foundations of the structure was built on what type of the soil stratigraphy, soil profile. And then nearest of the building, is there any slope face or is there any excavated slope? Of course, in Penang campus, we don't have so much hilly area, not like UiTM Shah Alam, not like in UiTM Shah Alam or Puncak Alam or any else. So we are having a failure of the building at the ground structure. Logically, if you have let's say you have high rise building with 10 levels of hostel building, grounded on the or built on the ground surface, flat ground surface. So you want to investigate what are causes to the structural failure. The structural failure can be observed from the crack pattern, crack dimension in terms of the length and width. And then you investigate more with having some geotechnical aspect, the geotechnical connections. What are the causes that created to the crack deformations? How do you relate the crack on the structure with the geotechnical aspect or technical informations? Because the building was standard on the building is standard on the flat ground surface. How come the crack can the crack can be formed? Macam mana retakan boleh berlaku? Apa punca? So you nak tahu, sebab kita punya bangunan bukannya berada dekat kawasan slope kan, contohnya kan, and then dekat kawasan tanah rata. So most likely maybe you can relate to the settlement, differential settlement, associative settlement, and then you go in detail. Settlement ni punca dia apa? Moisture content ke, ataupun the stress history, the pre-consolidation pressure. Macam mana kita nak highlight kan crack settlement ni ada some connection. Of course, you have to support your data from the site exploration, or you can have from the lab data. So that's how you presenting a forensic report. That I think from my own personal opinion. If you are only presenting your report that based on the sites chosen, okay, you observe this is the crack, and then you are not gathering all the information from the chapter 1, chapter 2, chapter 3, and chapter 4. Maybe if you follow to rubric, dia akan ada lah some rongga-rongga kan, void gap, yang mana markah tu tak boleh nak bagi dalam bentuk full mark. That's how I try to say, and that's how I try to bring you to relate all the information that you have gathered from the beginning of this semester to now. Okay, now just now we have seen the effect of berm, and then the groundwater level, the additional load, also the presence of the groundwater level decreasing the factor of safety value. And also, if you look at to the retaining wall, the dimensions of the retaining wall, you can see that by having some sort of the ratio, you can determine what is the best retaining wall design. Whether it is at the 8 meter or 6 meter, 4 meter, or at the 2 meter, with this kind of dimension of retaining wall. Somehow the retaining wall can be changed in terms of the size itself, the dimension, because you want to check the stability of the retaining wall by having this kind of the soil condition. We try to retain the slope face from failure by having a retaining wall. And then you have to decide on the retaining wall design, the dimension itself. Dengan lebar dia berapa, tinggi dia berapa, retain soil berapa tinggi, is it safe or unsafe for the soil structure. Okay, this is the conditions, the gabion wall design, telling you the best of the design dimension from the A, B, and C figures. So this one, I think that you can go by your own lah. Similarly here, just showing to you the combination between the berm and anchoring mitigation techniques. It says that if you have one slope and having anchoring, it is more better compared to the berms plus anchoring technique. So the FOS decrease as compared to the left image here. Okay, the other thing, when you are doing the mitigation or the slope management and monitoring, for example, these are the things that we need to get involved. For example, for instances, policies and legislation, and then the slope maintenance, construction quality control and site supervisions, and the other things is an additional info such as include in the module syllabus, and then the structure training for practitioner and having extensive research and development. Okay, kalau kata you Google for example, I have written on one research article regarding on the slope failure, and then analyze using the Platsis 2-dimension, and what I did was to investigate the slope deformation and also the stability of the slope. So I adopted one software, we call it Platsis. So the Platsis software is capable to predict the strength at the failure, and also it can give you the information what was the factor of safety during the slope fail. So that's good about using about using a numerical software in analysis. If you are using the manual calculation, for example, vertical slices technique or method, Fillenius, Bishop, the tedious work is that to determine what is the soil strength during the time slope fail. Itu yang dia akan jadi macam lecehnya kita nak do one to one try and error many times, and then try and error meaning that we insert one set of parameters, calculate FOS. Salah lagi ataupun tak stable ataupun stable, we masukkan set number 2. Because we want to know what was the strength parameter during the slope fail. So now we need to do the back analysis. In order to get the back analysis, factor of safety less than 0, kita tak tahu kan what is the exact the value of C and V. So kita pun cuba berkali-kali sehinggalah berjaya, sehinggalah kita dapat nilai FOS yang kita nak. Kalau kita guna software, kita masuk some certain input, and if the case study, case history has reported the soil strength at the field area, so kita gunakan the soil strength during that time, kita analyze menggunakan Platsis. So the Platsis will tell you the FOS the FOS less than 0. So kita boleh buat very fast justification, analyzing, and then we can go to straight conclusion to say that okay, during the time the slope was failed at this particular strength parameters, and in order to provide a mitigation technique, so these are the strength parameters that has been conducted in the present years. So inilah kita nampakkan perbandingan kalau you buat analysis untuk past period dengan future period, macam mana nilai FOS dia, and then macam mana kita nak mitigate. So the mitigation process become easier. It's not about the analyzing and design stage. It's also good if you are doing for the maintenance purposes and also for monitoring and controlling. So bagusnya kalau kita ada software ni untuk kita involve with that kind of the activity lah, untuk maintenance, monitoring, observations. Selain daripada tu, kita install some sort of the instrumentations. So the instrumentation will also helps the engineer to read the data and straightforward to the computer untuk kita analyze it. Okay, legislation policy ni selalunya kita akan involve with the public authority guideline lah. And if you look at here, DOE for example has tabulated a table which having different classes of the failures and also its limitations and the recommendations of the slope terrain, dia punya dimension berapa and the slope angle dia berapa, is it suitable for this kind of the soil properties, so you can follow the guidelines. So the guidelines can be referred at the initial stage of the design and analysis. Similarly, at the monitoring or any kind of mitigation techniques. ICRAM pun dia has their own table, IEM as well, and also IEM produce some slot geometry to give some idea what we call it as the total height of the slope, localized height, the global angle, and the localized angle of the slope. Okay, when you look at this circle image and the policies and legislations, it is very broad areas that being covered. For example, ensure the sustainability, enhance the safety, ensure slope stability and protection, ensure the environmental friendlies, and these are the things when we say that we are proposing any kind of the mitigation technique, we have to fulfill all those things. So not to forget lah, bila you buat sesuatu kecil kan, sebab forensik ni lebih cerita kepada benda yang dah berlaku kan, tapi kita pun boleh buat langkah awal pada ketika di mana you nak buat satu projek baru. Projek baru ni pula berhampiran dengan projek site yang dah pernah ada failure record. And then in order to prevent any future development construction facing the same problem that has been reported or recorded, so we can adopt the same information from the neighboring area. Maknanya bila kita nak design untuk site yang baru tu, kita boleh rujuk pada site yang dah mengalami kegagalan tu sebagai kita punya garis panduan. So our guidelines for designing, analysing and also for the verification purpose. Kalau kata kalau site yang lepas tu dia fail at this certain of the strength parameters, and then at the current site area tu the strength parameters is this certain value, and then you calculate, you check FOS less than 1. So how are you going to propose to your client? Adakah slope activity only involved with the excavation cut slope, ataupun after having the cut slope we are proposing also the mitigation ataupun protection slope. Apa teknik protection slope yang you boleh cadangkan, yang you boleh masukkan dalam kertas cadangan awak. Dan itu antara contoh-contoh macam mana kita menggunakan neighboring information site untuk kita gunakan pada our present future development project. So these are the idea lah. Okay, this is the policies legislation, the circles, its process, the parties involved. Okay, ini tak ada apa-apa lah. Okay, construction control ni, kalau kita tengok from the beginning of our lecture just now, the most important role is the site supervision and also the coordination. Make sure that our site engineer is sufficient with the knowledge and experience, having a closely toolbox meeting, and then close coordination, communication with the design engineers, and then maintain the detailed site record. Somehow site engineer kata macam ni, design engineer kata macam tu kan. So bila design engineer turun dekat site, lain jadinya. Site engineer tengok plan layout, lain. So dalam kes ni siapa nak jadi orang tengah untuk meleraikan isu antara site engineer dan juga design engineer. Itu belum lagi kontraktor campur tangan kan ataupun klien. Okay, dalam construction control, ini dia punya cycle dia lah. Start off dengan applies for temporary and permanent works, apply for legal provision, earthwork specification, and then the BOQ item for temporary slope protection works, and contractor to be penalized if not compliance to the guidelines. So this is the process can be adopted in the construction control. Okay, do you have any questions before we end our online lecture today? So far, your project report dah sampai mana? Jangan lupa assign attendance